if you would like to go back and watch them. I still try to record them.
I find it helpful.
I'm going to use
So-
my college pens because I love it.
Awesome.
Everybody gives me one of your stuff.
Our goal today is to find extreme values by using concavity. We've used extreme values, and we've used different ways to talk about our extreme values. If we were on a closed interval, we had to find those critical points and then test the critical points and the endpoints in the function itself. If we were on an open interval, we found our critical points and then did our line test to see, is our function going from increasing to decreasing, which would make a maximum, or from decreasing to increasing, which would make a minimum. Now we're going to be thinking about what if we can't perform a line test? What if I only know that this is a critical point without knowing what's going on around that critical point? So then, what options do we have if that comes up?
Use what you learned today to do it.
Exactly. So, I'm going to put two different functions up here just so we can kind of look at them separately. So if we want to know what happens at f prime of x, at our critical values, our extreme values, and what's going on at f double prime of x. What if we can only find specifically what's going on at one value? So our critical points are the extreme values of our function. Approximately on this first one, where is our extreme value at?
Approximately on the first.
Yeah, the first quadratic.
3.
thing. Approximately -3-ish. Okay.
I'd say about -3, 2, 4.
Approximate.
I was approximating.
So at that value, what do we know about f prime of x? If it's an actual extreme value, what do we know about the derivative?
That is when it hits the x-axis.
So it would be
0.
0. If we drew our tangent line, slope of that line is 0. We're used to saying f prime of x equaling 0 means we have a max or min. But what about saying, hey, I have a max or min? What does that mean about f prime of x? We need to be able to think,
Reciprocal?
yeah, that's a perfect word. Think of the reciprocals. You need to be able to go back and forth. So then, what about f double prime of x? Looking at my picture, what did f double prime of x tell us about a function?
Concavity.
Concavity. Okay. If we were concava, what do we know about f double prime of x? There's
It had positive length.
positive. I always think it's a happy face.
That's a pretty freaky face. Puts it in the house.
Don't mock my happy face.
Wasn't this little like
Or
snout?
else it will turn into a frowny face.
What about the second one? Critical point this time is like 3.5. What do we know about f prime of x on the second one? If we have an extreme value, what do we know about our derivative at that extreme value? Derivative is what? Still equals 0. It's still the same as the first one. But now let's see about f double prime of x. So this time,
Bless you. That was
We
an
have a frowny
unhealthy
face.
sneeze.
so we know f double prime of x is negative. So what's the only difference between those two extreme values? What type of extreme value is each of these?
One's a min, one's a max.
One's a min and one's a max. Which one's your minimum?
The first.
The first one was our minimum. Okay. Which actually feels kind of weird because it's when f double prime is positive.
When you hit the lowest one.
I actually have to hold up my concavity and say, okay, I'm concave up, my extreme value would be the bottom of this. Or I'm concave down, my extreme value would be the top of my concavity. Okay. So that's the basics of the first, or the second derivative test, or on the second derivative test. If we find that critical point, and we can find the sign of f double prime, we can tell if it's a minimum or a maximum. So we're going to start with an example where we could technically use the first derivative test. This is one where
That would be extreme.
That's why it's called extreme.
I could do the first derivative test because it's a continuous function that I'm working with, and I could do a line test. It's hard to find examples. Again, this is a detail. This is one of those things that on the AP test you're not going to see a lot, but if you know the details, then
Do we have one?
is this.
What's that?
Yes,
Ah.
is this. This is.
Can I borrow a calculator?
Yes. Bring it back by the end of class, please. Okay. So it's hard to find examples of this on the AP test itself because it doesn't occur very often. But again, knowing those details takes you from a 3 to a 5. So good to know anyway. So if we're going to find the extreme values, no matter what, when we find extreme values, we always need those critical points. So we need to start by finding the critical points. So what do we do to find our critical points? Eliana.
It's like 3, 4, 3, U. It's like counting.
Take the derivative, set it equal to 0. So we need to find y prime. So what rule do we have to use if it's a polynomial? Power rule. We just multiply exponents by our coefficients. So 4 times 5 is 20. We subtract 1. 4 minus 1 is 3. Minus 6x squared. Plus 14x plus 2.
Minus 0.
Equals 0.
Well, you know, there's a negative 3 and a 3 going.
Oh, I see what you're saying.
Nice.
I usually skip the minus 0 step though, because what's 2 minus 0?
7.
2.
Oh, dang.
But we do need to set it equal to 0 to find the critical point. How am I going to find where this equals 0? This is a calculator one. There's no possible way I could factor this.
Pretty sure.
Yeah, we could try grouping. I mean, I could look at grouping and say, okay, 2x squared gives me 10x minus 3 plus 2 gives me 7x plus 1. These have to match in order to do the next step of grouping. So when there's 4 terms, grouping's really our only factoring option. And it fails on this one.
So how does the calculator do it?
The calculator goes through an algorithm where it actually approximates using derivatives, zeros. We're actually going to learn in 5 what the calculator is doing to find this value.
As in chapter 5, or as in 5 years, or as in
We are on chapter 5, section 5, Thursday.
Oh dear.
X equals negative 0.132088. 0, 1, 3, 2, 0, 8, 8.
1, 2, 3, 4, 5.
Is that what everyone else is getting?
I got
So
I got
move the
two.
decimals here.
One.
Between the one.
So did I write it wrong, or do you have a 0 in front of yours?
I have the 0 in front of mine, but I could have plugged it in wrong. Let me check.
We
real quick.
have 0.1.
So same thing, but decimal is there,
Yeah.
and only one answer. And I do have 5 decimals. Why would I want 5 decimals?
Wait,
You're going to reuse it.
In case you have to reuse it. If this was our final answer, we'd just do that.
Wouldn't matter if I'm in log- if I'm in radians and not one.
You're always supposed to be.
I just want to double check since we did have.
Or this one.
So I want to go to algebra, menu, algebra, solve. Oh, they have a zeros one? That might be faster. It was 20x to the
Third.
third.
Minus 6x squared.
You're still in exponent.
Thank you. Minus 6x squared.
Plus 14x. Plus 2.
Like, is it just me?
And then don't I have to put comma x?
Oh, I put equals 0.
Yeah.
You have to put
Oh,
equals 0.
Yeah.
thank you. Sorry.
Yeah.
Okay. So yeah, we are only getting a 0.1, no 0 between the decimal and the 1. Okay, so there's our only critical point. We only have one critical point. Now again, technically we could perform the line test, but that's not how we're going to handle this because we're going to practice second derivative test. So after we find that critical point, we actually find f double prime of x. I want the second derivative because the second derivative can tell me what's the concavity of the picture that I'm looking at. At this specific point, am I concave up or am I concave down? Because if I'm concave up, I have a minimum. If I'm concave down,
Maximum.
maximum. And like I said, literally I have to hold my hands or I forget which one is which. I have to say, okay, concave up. Bottom point would be my extreme value. So we need the second derivative, 60x squared minus 12x plus 14. Again, just power rule. We don't have to do anything fancy with this one. So then, if we want to find concavity at this value, we want to plug this value into f double prime. If we know if this answer is positive or negative, then it can tell us the concavity. So plug into f double prime of x. And again, we don't care what the actual value is. It could be 5 million. I don't care. As long as we check for the sign. We want to check if it's positive or negative. So again, this one is a calculator active question. There's no way I know how to square 0.13, well, okay, technically we could square 0.13208. We don't really want to. So we're going to plug this in using our calculator. And I could actually figure out the sign of this particular one without even plugging it into my calculator. What happens when we square this?
It becomes positive.
Positive. What happens when we do negative times a negative?
It becomes
Positive.
Positive. So if we have positive
Yeah, 14.
plus positive plus positive, then it's definitely positive.
Oh, I thought it was negative.
If
Oh, it's positive.
positive. If it's not as simple as that, we would have to actually plug it into our calculator and get a value, but that one we can easily tell y double prime is greater than 0 at that point. So now we make a conclusion. What do we know about x equals negative 0.13208? Is it a maximum or a minimum? We are concave up, so we are a minimum. Like I said, literally, I have to visualize this one. I don't know why my brain will not. That's not the same for everyone. Just my brain. I have to visualize. So we have a minimum. F of x has a minimum at x equals negative 0.132. And then we need to give some reasoning behind this, because f prime of x equals 0 at x equals negative 0.132, and f double prime of x is greater than 0 at, again, we have to be super specific. We can't just say, because we found the critical point there, they're going to be like, well, how did you find the critical point? We need to be super specific with reasoning like this. On the AP test, if they ask for any sort of reasoning, be very specific. It's better to over-explain than to under-explain. So again, this problem I technically could have done a line test. And personally, I prefer line tests because it's the one we work with way more often, so it's the one we remember a little bit better. But it's also possible not to be able to perform a line test. Does everyone have this written down before I continue though? Okay. Yes? No?
I just realized something.
Okay.
SAT thing, my math score, about 1500, 600. So I think I'm a genius, but not.
Okay. Find the extreme values of y.
Why?
I think I may have not included enough information on this. Now that I'm looking at this again. We'll try it.
There's no F triple prime. I can't do it.
We don't do that triple prime. It's a jerk.
Math too.
I got it.
Got that.
Okay.
So on this one, I don't have an actual function for f or for g. So I will not be able to perform a line test no matter what. I think I did set up my table incorrectly. We're going to find that out in just 1 second. Well, let's first take the derivative.
So should we write this then?
You can ignore the table for now. Sorry. We will end up utilizing it, just I think I wrote it down incorrectly when I was, last year I wrote it by hand and then I typed it up this year. And so I think I made a typo when I was doing that. I misunderstood how I wrote it out last year. But first, what's our first step anytime we find extreme values, no matter what's going on?
Derivative.
Derivative. I need y prime. I need to know where y prime equals 0. So looking at this function,
Product rule.
Ben is correct. We have to use product rule. It's a must. It's the thing that we forget most often.
And I remember.
Okay, so f of x, what's the derivative of f of x? And
it's 5.
g of x, g prime of x. Then we do low d high plus high d low, or second times derivative of the first plus first times derivative of the second. So g of x times f prime of x plus f of x times g prime of x. Let me see if I can get the table to move. Come on, let me select you. There. I don't even know how it switched pages. Well, it's gonna be really squished. So with this problem, I did need to give you more information. I needed to tell you where my critical point was at. What would happen if we tried to set this equal to 0 right now? We wouldn't be able to solve it. So find the extreme values if y prime equals 0. At x equals, doesn't really matter, 2. So we'll say all of these are at x equals 2. So I should have put an x column and a y column. Like this would be the y column. It's backwards, I know. And the x column, these would all be 2's. It is. So I will fix that for next year. So if we know we have a critical point at 2, then y prime actually doesn't matter. We already know where our critical point is, but we have to find y prime in order to find what? Y double prime. I still need to know concavity in order to say if this is a max or a minimum. So I now need y double prime. So again, I'm going to have to do product rule with each piece. Derivative of g of x is g prime of x. Derivative of f prime of x is f double prime of x. Then I have to perform product rule. The next piece, and I also have to perform product rule. So I want you guys to find the derivative, second derivative of y. Finish the product rule. So you should have gotten f prime of x times g prime of x plus g of x times f double prime of x plus, then we go to the second piece, g prime of x times f prime of x plus f of x times g double prime of x. And we could do a little bit of simplification. What could I actually simplify on this? There's two of the same thing. So I could write this as y equals 2 f prime g prime. I'm going to stop writing the of x just because I'm lazy. No other reason.
on the AP test?
No. No, you cannot. So, what do I have to do to still find the sign at our critical point?
You need to plug in numbers to see if it's possible.
Plug in what?
Y values of x equals 2.
Well, yeah, we need the y values at x equals 2. We need to plug in 2 everywhere we see x, which I was lazy and didn't write, and then the y values. So now we really need to utilize our table. We have 2 times f prime and g prime. 5 times 4. Thank you. Plus g at 2 is, I can't see my table anymore, so 3 times f double prime, -2 plus my f value times g double prime, and I can't actually see. -7, so we have 10, 40, -6 minus 7, which is definitely, again, positive. Again, I don't really care about value, but we could find it. 27? Yep. Positive. So if we're positive, do we have a maximum or a minimum? Minimum. You're right. Like I said, I always have to think about it. I want that to be maximum so much. I don't know why. Min at x equals 2. And again, we could give that entire reasoning. That was kind of to introduce the reasoning. Really just give me where the min or maximum occurs. So I'm going to have you guys try one. This one will, again, technically you could be able to do this with the first derivative test, but I want you to do this using the second derivative test, just because we're practicing the second derivative test. So what should our extreme values be? Evelyn?
Max of -2. And then,
Make sure to put x equals -2.
and then x equals -2. I mean, x equals 2.
What if I wanted you to actually give me the max and the minimum values? If I said find the maximum. Plug them into the original and get whatever value out that would be. So for the homework, there we go. And then I have one free response question I would like you to do. And you can actually do all 4 parts of this free response question.